कैसा बोल रहा है?
दूर हट जाओ, ये फट जाएगा।
अरे हाँ, फाउंटेन बन गया इसमें। बारिश हो रही है उसकी।
नेचुरल स्प्रिंकलर।
चिपचिप हो गया पूरा हाथ में। नहीं होगा, वो फट चुका है।
बढ़िया पानी।
ये उड़ता ना अगर।
Hey, good morning, students. Again, I am with my experiment and with some explanation. So, again, this is my request to you. If you know the explanation, so you can just skip this explanation and go to the experiments. I have lots more video. For my purpose of this tutorial is just to show some experiments and some some topics knowledge also, as well as experiment, so that you can quite link between the two. Okay, so let's have a first experiment explanation that you saw just now. Experiment 1. What's that? It is balloon plus baking soda experiment. Balloon plus baking soda experiment. What's that? In the balloon, I have put that baking soda in it, and in my bottle it was lemon juice. So the reaction is something like this: baking soda. I have filled my balloon with baking soda. You can just 1 spoon of baking soda is enough for it. Baking soda plus lemon juice gives you salt plus CO2 plus water. So you saw a lots of effervescence in that bottle, due to which because of this CO2 gas which comes out as a reaction of these two, and the balloon blows up. And unfortunately, because of that blowing time, my balloon just got burst, and you saw a little sprinkle from that. But believe me, if that balloon didn't burst at that time, then balloon get filled with that gas and it just blows up. Maybe sometimes it blows up, and sometimes it happens balloon just blows up with all full of its circumference. Okay, so because of this gas, CO2 gas was in that balloon. Okay, so what is this baking soda? Baking soda is simply a carbonate, and lemon juice is acid. Right, so carbonate and acid, as you know in chemistry, carbonate and acid gives you salt plus carbon dioxide plus water. So, and this change is, you know, many students learn the topic chemical irreversible change. Chemical irreversible change. So this is an example of that chemical irreversible change. So I just put my balloon in the mouth of this bottle, and when I blow this balloon from my mouth, look what happens. So you can easily see it will not blow, right? Now, if you pierce a hole in it, then look what will happen now.
Baby border.
So you can easily see when I just suck the air and the balloon blows up. So what is the principle behind it? I will explain later on. So my experiment, you just saw a video of experiment 2, and it is that blow balloon from side of bottle. Wow, what a headline. Okay, in this what I did, this was my bottle. Wow, very nice bottle and cap, right? What I did first, I just heat my nail and pierce one hole in it on its side of the bottle. Okay, I did this since I want to pierce it and I don't have drilling machine, so I just use this technique. I heat the nail on my burner and just pierce the hole. Okay, I just showed you this technique in the video also. So now the bottle has one hole in it, and what I did, this is my balloon. Okay, in it, my balloon. Okay, this is now if you just take your mouth here, and here is of course hole. So you just do one thing. First you put your hands over here, and when you try to blow this balloon, it will not inflate it. The balloon will not blow up. Okay, because the balloon will not blow up like this. Since it has a reduced pressure and the pressure outside is very large, so balloon will not blow up. As you release it and try to suck the air, now when the next step is, you just put your mouth here, and just try to suck the air from the bottle. Suck air from bottle. If you try to do so, you are just sucking the air, you're just reducing the pressure, right? You are doing so. So what is happened? You are reducing air pressure by sucking air from balloon. So what happens? Balloon expands now. Balloon expands. Why balloon is expanding? Just to equalize air pressure inside. Okay, so that's why balloon expands, because you are sucking, so balloon just expands to equalize air pressure. Okay. What is the color of this balloon? Green. Wow. 1, 2. Now my experiment third. Experiment third is balloon fountain. Okay, what is this balloon fountain? What I did, I just take a bottle, of course I pierce it and put a straw in it. Okay, and put a straw in it and fill the bottle up to neck. Okay, this is my water. What I saw is I just do a straw upper what you can say, it's mouth of upper straw, upper side of it. I just do like this so that water will not come out. Now since the pressure outside, atmospheric pressure atm, atmospheric pressure and pressure inside is just equal, so water will not come out. What I did, I just put an inflated balloon in it. Now this inflated balloon has higher pressure. This has higher pressure. And this higher pressure puts the pressure on the water, on the top of this water. So water pushes down and it pushes down. So it just, since it is pushing down to the so when it goes down towards the bottle, that is lower pressure. Due to this pressure, water pushes down and causes rise. This causes rise through the straw, making a little fountain. Water sprinkles out. Fountain. Okay. This is my bottle. This is higher pressure, and here, since higher pressure goes like this, so water pushes down, and here is my straw. Okay, so again balloon, higher pressure, water level goes down. Since it is pushing, higher pressure pushes it. So now the water where water goes, it has to equalize that pressure, so it rises from the straw and come out of the bottle. So this is the basic principle of it. Okay. So as you can see, my bottle is filled now and no water is coming out. Now what I did here, I just pierce with this pin, I just pierce a hole at the bottom of my bottle, and since the cap is tightly closed, so what is happening, outside air pressure, inside is same, so no water is coming out. Now look, let's see what happens now. As slightly I just try to open it up. Look what happens. Hope you can able to see this is sprinkle now, and now again close. So again, as I releases the pressure, the air outside is rush into the bottle, and look this sprinkling of water. Okay, hope you can able to see this sprinkling, a sprinkler fountain. And as this level of water coming down, look, can you see this level is coming down now, the velocity of the water sprinkle out, the shooting of water, it's just now the velocity is quite less. You can see as height reduces from the level, as height reduces from this hole, look, the velocity is reducing. Look, the velocity, before that the velocity was like this, the shooting velocity was like this. Now look, As the height reduces, the water level, the velocity of water coming out of the bottle is also less now. Now just close the cap. Experiment 4. This what I did in this experiment, I took a bottle, cap closed, and filled this bottle up to neck with water. Okay, fill this bottle. Now before that, I just take that Septipine's needle and pierce some hole in the bottle all around. Okay, all 360 degree. I pierce some hole in it. This is my hole. Okay, now when the cap is closed, you saw no water is coming out. So what is the reason behind it? Because air outside pressure, and since you just put the cap, so it is equals to inside pressure. Okay, outside pressure is equals to inside pressure, so that's why these two has equal pressure, so no water is coming out. Okay, can we name this experiment as water exerted by air, force exerted by air pressure? So what is this happening over here? Water pressure inside is when you just now I have taken off the cap. As you taken off the cap slightly, water pressure inside is greater than outside air pressure. So what happens, you just saw that, look, the height of water is here. From this height to this hole, height is greatest, so velocity of this will be greater. And since height here is quite lowest than this, so velocity of this will be lowest as compared to, not lowest, I mean to say lower than this hole. The reason is, I will show you one more thing with some mathematical formulation so that you will understand better. Suppose a ball is here and we just dropped it. When you are dropping on the ground, this is my ground, you know that here is velocity 0 and width and the height is h, let's say, and the ball has mass m, let's say. Now at this point, if you apply law of conservation, and not at this point, but if the ball is releasing here and if you apply the law of conservation of energy, it says total kinetic energy is converted to half of total kinetic energy is converted to mjs, that is potential energy. So we can have m to m cancel, v square is equals to 2gh, or v is equals to under root of 2gh. Correct? So what we seen that v is directly proportional to height. So the same principle apply here. Velocity of water is higher that point where height is lower. If height is more, velocity will be more. And if you pierce hole over here, so height is less. Upper surface, you have to measure height from the upper surface, so height is less, so velocity will also less. So as it goes down, velocity will increase because height of the water is increased. Okay, now you may ask questions, water is coming down gradually, so again, of course height is changing, but you can do one thing, you just put your bottle in the in the tap, and water continuously coming out, so you can observe this phenomena. And even if you're not putting it in the tap, you can easily observe this. When water is here, the water at this point, the velocity is less because height is less, and height is more, the velocity is more. So this is the basic principle of it. Hope you liked the video and enjoyed, and maybe some concepts got clear from it. Thank you so much for watching. Have a nice day.